A strange radio emission is detected between two clusters of galaxies that are going to collide June 10, 2019. A team of European astronomers has captured unusual radio emissions between two clusters of galaxies that will collide. It is the greatest cosmic connection of this type ever observed, and its main interest is that there is no apparent explanation of how such a thing can exist. A strange radio emission is detected between two clusters of galaxies that will collide, one in 2013 and 2016. The Planck satellite revealed the first signs of a particle stream that runs over 10 million light-years away and connects clusters of the galaxies Abell 0399 and Abell 0401. The clusters are the largest structures that exist in the visible universe sustained by gravity. They contain thousands of galaxies and tend to form at the intersection of other large structures known as filaments, which form a kind of spider web known as the cosmic network. After knowing the details of Planck, coordinated by Federica Govoni, astronomer of the National Institute of Astrophysics of Italy, the team observed two clusters with the LOFAR, a large radio telescope with antennas spread by several European countries, whose central body is in Holland and is one of the most sensitive in the world in the low-frequency range. The results, published in the prestigious scientific journal Science, confirm that the radio emissions are due to the presence of electrons traveling almost at the speed of light by a magnetic field connecting two clusters of galaxies. Govoni explained, "We usually see these emissions between individual galaxies or within a particular cluster, but there has never been an emission between two clusters." The two clusters studied are 1 billion light-years from Earth. If humanity had planned a way to travel at the speed of light, it would take 1 billion years to reach Abell's two clusters. The sad reality is that, as Wired magazine has calculated, the fastest spacecraft ever built reaches only 0.0002% of the speed of light. A strange radio emission is detected between two clusters of galaxies that will collide to aerial view of the antennas of the LOFAR telescope. Each of the clusters studied has a mass billions of times greater than the Sun. At this moment they travel in a frontal collision trajectory at 1,000 kilometers per second. Govoni explains, "It is possible that the connection we observe is a first sign that confirms something we already know. Both groups will collide and merge into one, but that will only happen billions of years from now." The discovery is disconcerting to its discoverers. The phenomenon observed is known as synchrotron radiation and happens when very energetic particles move within a magnetic field. The problem is that it is very difficult to explain the nature of these radio signals as an electron. According to Govoni, astrophysics christened its discovery as a cosmic dawn because of its resemblance to terrestrial auroras that occur when highly energetic particles spewed by the Sun hit the Earth's atmosphere in the polar regions. In their study, astronomers made simulations to try to explain the phenomena. His conclusion is that within the magnetic field there may be shock waves capable of accelerating the electrons. Madhuro Murja, co-author of the study, explains, "These shock waves are similar to those produced by nuclear bombs or stars that explode in supernovae." The simulation shows that electrons are not traveling in a straight line, but rather in a chaotic way through the vast magnetic field that connects both clusters of galaxies. He says, "According to our study, the particles enter a discontinuity within the gas and gain energy. It's like you throw a tennis ball on a busy road. The cars are pushing the ball and this is gaining more and more energy and speed. The question is whether these turbulences occur due to the presence of very massive and relatively recent objects in the history of the universe, such as black holes that may exist between the two groups, or, as predicted by the study, anomalies were formed shortly after the origin of the universe 13.7 billion years ago." The next target of these astronomers is to confirm other similar bonds that have already been detected among other clusters and to look for new clusters more distant than those studied, that is, much older, which would help to determine which of the two options is correct. Were these physicists tempted to think that radio transmission could be fabricated? Murja considered, "It would be impossible for any intelligence to eject particles with such energy that it would be able to run 100 times the distance from one end to the other of the Milky Way. What is not so improbable, considering the billions of possible planets like Earth in the universe, is that someone is now asking the same questions in another galaxy.